First, couple news items, 3 news items, I guess. The first one is quiz 1 is going to be on Wednesday. And remember to get ready for the quizzes. You want to go back to the beginning of your notes, the beginning of the class, and just read through your notes. These are going to be short answer questions about just stuff I say. I try to focus on what I consider to be big points and not kind of details or whatever, but that's kind of in the eye of the beholder, you know. And that's going to be in the last 10 minutes or so of class on Wednesday. And then exam 1 is a week from Wednesday. So that would be the 18th, 25th, I think. Yikes. I just want to check the date. Yeah, 25th. Okay. And the last thing is weekly assignment 1 is posted now. And so those problems should be similar to problems you've seen in the homework assignments and stuff. If you have questions about those, I'm happy to give little hints and stuff. I'm not going to go into as much detail as I would with the daily problems talking about them because it's part of how I evaluate this class, but I'm happy to give you a little boost if you get stuck. Okay, anybody have any questions about any of those?
I'm assuming they're not open note, are they?
The exams are closed notes, but I'll give you every equation and any conversion factors you need.
Okay.
Yep. Yes.
And the exam again is just like everything that we've learned.
Yeah, basically think of the exams as like it's just really measuring how well you understood the homework problems. You know, if you understand the steps for doing all the homework problems and you could explain it to someone and that kind of thing, then you'll do great on the exams. Question?
Exams looking like short answers, some of them.
It's all just problems. So it really just looks like a collection of problems from the homework, you know. It won't be those problems, but it'll be the exact same thought process. Every problem should look very familiar, like, yeah, we did this on this assignment.
Do you give like half credit?
Yeah, for sure. I give a lot. I mean, so I'm basically just grading based on the process you follow. That's why I said it, like I don't care about rounding or whatever. Like, I just want to see that you're doing the steps right. And you know, sometimes if you can get a wrong answer, but I'll look at it and be like, oh, I know they know it. They missed a negative sign here or whatever. And you can get full credit sometimes on problems where you don't get the right answer. It's really all just about the process you're finding. I give a lot of partial credit, yeah. Yes?
The quiz isn't like math problem.
Correct. The quiz is just short answer questions about what I've said in class. So like an example might be like, when an object in projectile motion reaches the highest point, what do we know about its velocity? Okay, and you just write velocity is equal to 0, that kind of thing. So no calculations, you won't need a calculator or anything. Was there another question over here? Okay, anything else? Okay. All right, well, let's just start with some examples. And with these examples, so for one thing, feel free to work together, talk out loud. You know, you don't have to whisper or anything. Like, it's just kind of a chance for you to solidify some of these ideas with me here and other people here. Feel free to compare answers along the way as you go. And feel free to ask me questions as you're working on it if you get stuck. And then once you're done, I'm going to go through it. And the idea is it can help you find places where you're thinking about something wrong, you know. That's the idea. Or at least, or if you did everything right, you know, give you confidence in that. But the main benefit is if something goes wrong, you can identify where you had a misunderstanding. Okay, so the first one. This is a human cannonball. I don't know. Have any of you guys ever been to a circus? Do they still have circuses? I think sometimes I see. I think maybe when I was a kid they were a bigger deal. Maybe because of all the animal abuse. I think that might have led to their decline. But I did love circuses. Anyways, there was this thing where they would have like a long cannon looking thing. And inside there was some kind of mechanism with a platform that would launch somebody. So there's somebody inside like this. And when this, whatever launches them, the spring or whatever it is, it shoots them out of the cannon. They fly a whole long way and then land in a net. And so let's say this person, this person needs to go from rest to a speed of 12 meters per second over a distance of 2 meters. So we're talking actually about the motion inside that cylinder, not the flight. And I want to do, I guess let's just do one question here. What's the acceleration during this 2 meters? Okay, so take a few minutes and see if you can work through that. I'd recommend if you're still hazy on the steps, feel free to look at your notes for now. You know, you just want to build good habits here. But remember that in 9 days on the test, you won't have your notes. So little by little, you want to get used to just following a process that you know you're not going to forget steps to and stuff like that. Okay, go ahead. Like I said, talk to each other out loud, ask me questions out loud. So the path that we're talking about here is, you know, it starts down here with the person's center of mass down at the bottom of the cannon and ends up here. And the distance is 2 meters. And we know that the speed is 0 meters per second when the person's down there, and it is 12 meters per second. Is that what I said? Up here. I think probably just about everybody now, you know, the first step is you choose your zero position, your positive and negative directions, and when you turn on and off the stopwatch. I think probably just about everybody chose the zero position to be here and the positive direction to be this way. You don't have to do that. And so I think hopefully this won't just make it more confusing, but I'm just going to choose a different point because you can choose anything you want. So I'm going to choose my 0 here and my positive direction to be this way. And we'll see how the answers look compared to the answers going the other way. So based on this, if the person is at 0 position when they leave this cannon, what's their position at the start of the motion? You start at 0 and go 2 meters in the positive direction, so this would be positive 2 meters. Okay? And for the velocities, that starting velocity would be 0. And that ending velocity, notice that the person is moving in the negative direction at that point. So that would be negative 12 meters per second. Okay? We have to, for anybody to get this problem right, there's only one choice of time equals 0 and time final. So what's going to be the time equals 0 instant? That's like, yeah, at the start of the motion or when the person's at rest. And time final is going to be when they reach 12 meters per second of speed. And now we have to list out what variables we know and want. Do we know what the stopwatch says when we turn it off to look at it? No. We're trying to find the acceleration, so we don't care about that if we don't need it. Do we know the acceleration? Yep, that's what we're trying to calculate. Do we know the position at time equals 0?
Yes.
Yeah, what's that the way I have it in this crazy way? Yeah, that's, so initial position is positive 2 meters. Do we know the position at time final? Yep. Do we know the velocity at time equals 0? 0, yep. And do we know the velocity at time final? The speed is 12, so I like to think of it like this. It's definitely going to be plus or minus 12. And now we have to think of how that relates to our directions. It's in our negative direction. So it's this way, okay? On yours, it's almost certainly positive because most people would choose the positive direction to be the direction it's moving. And now we're looking for an equation that works. I think this one should. 2a times the quantity pf minus pi is equal to vf squared minus vi squared. So 2a times the quantity 0 minus 2 is equal to negative 12 squared minus 0 squared. And so we get negative 4a is equal to, now notice that this negative is inside that square. And so that becomes positive. And so this is 144 positive. And so A comes out to be negative 36 meters per second squared. Okay, if you did this problem right, you most likely got A equals positive 36 meters per second squared. So how is it that we got different things? Well, notice that, that sign just tells us the direction of the acceleration arrow. So we could think of this as, we could think of this answer as 36 meters per second squared, pointing in the negative direction. And my negative direction is this. And if you wrote your answer as a magnitude and a direction, you would get the exact same thing I did. Okay? So that's how they give you different numbers, but the interpretation means the same thing. Okay? And then, do the sanity check. is the person over this motion speeding up or slowing down? Speeding up, so velocity and acceleration have to have the same sign. The way I chose it, mine are both negative, so that's good. The way you probably chose it, yours should both be positive. Would the person survive this acceleration? That's an important question in designing a rinky-dink circus. Yes, the person would survive. This is, so the way people think of like high accelerations of people is in terms of G's, you know, like fighter pilots or whatever, like if they do a maneuver, like how many G's of acceleration is being required. So 1 G acceleration is 9.81 meters per second squared. So this is a little less than 4 Gs. And that is a big acceleration, but any person will stay conscious during a very short acceleration of 4 meters per second squared. You know, that's no problem at all. Okay, let's do another one. So let's say that an object moves to the right with a constant speed of 20 meters per second for 15 seconds. How far does the object travel? And this is a pretty simple question, but there's a reason that I want to do this. This is a question, I mean, if you visualize what's going on here, this is a question you're used to answering. You don't even really think of it as an equation, most likely. You know, if you're going 60 miles an hour for 2 hours, how far do you go? You just multiply those two together to get a distance. And if you had to put an equation to it, you would think distance equals rate times time, or some version of that probably. I just want to point out that yes, in this problem, you can solve this problem using distance equals rate times time. But instead of using distance equals rate times time, which is only applicable when you have zero acceleration or a constant speed, constant velocity, think of using those constant acceleration equations and just fit in the variables. It'll keep you from using distance equals rate times time in cases where it doesn't apply, when you do have an acceleration. So I just wanted, this is one where our constant acceleration equations, if you do everything right, will reduce to what you're used to using, distance equals rate times time, in the case that the velocity is constant. Okay, so take a couple minutes and do this. I don't think it'll probably take. We're going to the right from here to here. The total time is 15 seconds. The object is going 20 meters per second that way at the first point, and also 20 meters per second at the second point. And one thing, just to fit this into the equations as fast as possible, I want you to notice that constant velocity, I've mentioned this before, but constant velocity and zero acceleration mean the same thing. And so we're going to, you can either say that you know, so either say you know v final, or say you know the acceleration is 0. Not both. That's, you can get by saying both, but it'll make it look like some equations will work that won't work. So this is just a way to kind of avoid going down a little short dead end. And so what I'm going to do in this is I'm going to pretend I don't know what VF is, and I'm going to say I know that the acceleration is equal to 0. Okay. And let's list out what we know and what we want. Time final is 15 seconds. I didn't choose the 4 things we have to choose. I guess I'll choose 0 position here, positive direction this way, negative is this way. And time equals 0 is the start of the motion. And time final is going to be 15 seconds. Okay, so at time equals, okay, we know that the acceleration is 0. That's what I'm going to use to say that we have constant velocity. The position at time equals 0 is 0. The position at time final is what we're trying to find. The velocity at time equals 0 is plus or minus 20 meters per second. And is it moving in the positive or negative direction? Positive, yep. And last, I'm gonna not even say that I know V final. Obviously, it's also positive 20 meters per second, but that would just lead you down a little dead end. And now, what equation can we use to find PF? I'm going to use this equation. PF is equal to PI plus VITF plus 1/2 ATF squared. So PF is equal to 0 plus 20 times 15. Since A is equal to 0, this whole term goes away. Anything you multiply by 0 is 0. And so what you get here is this, because it's constant velocity, this equation reduces to distance equals rate times time. And you get that PF is equal to 300 meters. Okay. Okay, so now let's get into some projectile problems, and I'm just going to try to cover a lot of the little things that can come up in these. So let's say that an object is launched straight up at a speed of 8 meters per second and from a height of 2 meters off the ground. And so the first part, I'm going to break this up into 2 parts, and we'll first go through A, and then I'll do it, and then we'll go back and do B. But the first part is, how high is the object at its highest point? Okay, so take a few minutes and see if you can work through that. So I think it's helpful to, at least often it's helpful to draw a little diagram of what's happening. So this ball is being launched from a height of 2 meters. And it's going up into the air, reaching a highest point, and then coming back down the way it came. And we're trying to figure out what this height is at the highest point. In these free fall problems, I always choose my 0 position to be the lowest point that's like referred to in the problem. So that would be the ground in this case, since we're measuring heights from the ground. And my positive, I always choose up, so the negative is down. And then my time equals 0. When do we want to turn the stopwatch on?
Toss it up.
Yep, the instant it's launched. And then what's the instant that we turn the stopwatch off to look at the time? Yeah, so that's velocity equals 0. Yeah. So right, this is going to have to be when the thing reaches the highest point, however we refer to it. So this is the instant it reaches the highest point. And now we can go through what we know and what we want. Do we know what that stopwatch says? Time final? No. We're okay without it if we can get by. Do we know the acceleration?
Gravity.
Right, it's free fall, so that's a no-brainer. That's always down at 9.81. Whether it's on its way up or on its way down, the acceleration is always the same. Do we know the position at time 0?
Yeah, 2 meters.
Yep. Two meters. Do we know the position at time final?
No, that's what we're saying.
That's what we want, yep. So P final is what we're looking for. Do we know the velocity at time 0? Okay, so I'm going to write this as plus or minus, and we're given that the speed is 8 meters per second. And then is it moving in our positive or negative direction? Positive, I chose positive up. And then the last one, we've been waiting for this the whole time. When something reaches the highest point, what's its velocity?
0.
0, yep. So V final is equal to 0. And now we're looking for an equation that'll solve these. I think it should work to do 2A times the quantity PF minus PI is equal to VF squared minus VI squared. So 2 times negative 9.81 times the quantity PF minus 2 is equal to 0 squared minus 8 squared. And it's really important that you notice that the minus from this equation is not being squared here, or it'll mess everything up, because if you square that negative, it'll turn positive. And so now we have negative 19.62 times the quantity PF minus 2 is equal to negative 64. Divide both sides by negative 19.62. And you get PF minus 2 is equal to 3.26. And then add 2 to both sides, and you get PF is equal to 5.26 meters. And that's a position, so like, remember that what this says is, like, it's easy to get yourself confused, like, oh, is that how much higher it went than from when it was launched? That's a position. So it means what the position tells you. It means from our 0, you go 5.26 meters in the positive direction, and that's where this is. So 5.26 meters off the ground. Anybody have any questions about that? So now for part B, how long, and I'm talking about time, is the ball in the air before it reaches the ground? And with these examples today, I'm trying to hit a bunch of the sort of tricky things that can come up in these sorts of problems. Can anyone look at this and tell me what you have to be careful of? What's the pitfall here that, yeah?
And you don't know taking into consideration the stopwatch, like basically stops it whenever it stops.
Yes, exactly. So if we use our time final from part A, we won't be able to solve this problem. If you just plug this straight in and calculate time final based on our old choice of what time final was, you would get how long it takes for the ball to reach its highest point, not how long it takes for the ball to go all the way up and back down to the ground. And so you're going to want to choose a different time final meaning for this part. And that's going to change what some of your variables are. Okay, so take a few minutes and see if you can go through this. This one. So the time equals 0, meaning we're going to keep the same. So that's still going to be the instant that the ball is launched. But time final now is going to be the instant that it reaches ground level. So that means that some of our variable meanings are going to change. Well, what it means, since we kept time equals 0 the same, all of the initial values are going to be the same, but all the final values are going to change because time final changes. So, okay, we're trying to figure out how long this takes. So time final is what we're trying to calculate. Acceleration, it's still in projectile motion, so this is still negative 9.81. Initial position is still positive 2. Do we know the final position? It's when it gets, we put our 0 at the ground and we want to calculate when it reaches the ground level. So our final position is going to be 0. Our initial velocity is, what was it, 8? Yes, positive 8 meters per second. And do we know the final velocity? When it reached the highest point we did, but we don't know what the velocity is when it reaches the ground level. It's going down at some speed. We don't know what it is. Anybody have an idea? So it's going to be negative because down is negative. How is it the speed going to compare to 8? Is it going to be bigger than 8 or smaller than 8? Any idea? What? Well, here's how I know. So like if it gets launched up from 2 meters, goes to the highest point, returns back to 2 meters, there's a symmetry there that says it has to be a velocity of 8 meters per second down when it returns to that ground level. And so then it's going to speed up for 2 more meters. So it's going to be a little bit faster than that. It's going to be negative 8 point something, probably maybe 9, you know. Okay, so is there an equation that works with these? Let's see. Yeah, we can go PF is equal to PI plus VITF plus 1/2 ATF squared. And so that says 0 is equal to 2 plus 8TF plus 1/2 times negative 9.81, that's minus 4.905, times TF squared. And now you need to use the quadratic formula for this. So to use the quadratic formula, this is A because it's multiplied by the variable squared. This is B because it's multiplied to the variable, linear variable. And this is C because it's the constant. And like I said, anyone with a TI graphing calculator, if you haven't yet, come talk to me in lab or something, and I can program the quadratic formula in so you never have to think about that anymore. But we know that the roots are going to be negative b plus or minus square root of b squared minus 4ac all over 2a. And that always gives two roots. And the roots that you should have gotten here are negative 0.22 and positive 1.85. In this class, we're never dealing with negative times. And so when you're doing the quadratic formula for a time, you can always just eliminate any negative one you get. And so this is the answer. Anybody have any questions about that? There's one thing I wanted to point out, so there's always physical meanings to the, when you take the square root of a variable and you get plus or minus answer, or use the quadratic formula. There's always a physical meaning, a semi-physical meaning for the answer that you're rejecting. So let me show you what that means here, okay? Anytime you draw a position versus time graph for a projectile motion problem, it's going to be a quadratic shape, a parabola. So there's a parabola. And the equation itself doesn't know when the physical meaning of this ends. It doesn't realize that there's a ground here and we're done being interested in this parabola after it hits the ground. This happens at 1.85 seconds. But this keeps going. And over on this side, it keeps going too. It doesn't know that at time equals 0 is when the ball is launched, and before that, the ball is just sitting in a launcher or something, or being carried over to the launcher by someone. And so this second root is when the math thinks the ball reached ground level on the way up. Okay? If this motion continued infinitely long before and infinitely long after, this happens at negative 0.22 seconds. So you can always think of that as the meaning of, like when you use the quadratic formula, that's the meaning of the time that you reject. It's like if this ball wasn't launched at time equals 0, but was launched long before that, it's when it reached that height on the way up. Okay, I want to do one more problem. So let's say that a helicopter is moving straight up. At 3 meters per second. And the people in the helicopter drop an object from a height of 15 meters. And we want to calculate what's the velocity of the object when it reaches ground level. Okay, there are kind of two things I wanted you to get practice with in this one. The first one we can talk about before you start. So this object is dropped from a helicopter. Do you remember what the rule is for something being dropped from a vehicle or? Yeah, so at the instant that it's dropped, it has the same velocity as what it's dropped from. So that means that even though this ball is just, the person just opens their hand and lets go, this ball acts as if it was thrown up into the air at 3 meters per second. Okay? So take a little time and see if you can work through this. So to sketch what's going on here, I'm just gonna sort of translate this into, like, we don't even really have to think about the helicopter. We can just think it's released from a height of 15 meters. And at the instant it's released, it's moving up at 3 meters per second. And so it's going to go up a little bit and then come back down. And we want to figure out the velocity when it comes down and reaches ground level. I'm going to put my 0 position on the ground, my positive direction up, and my negative down. And then time equals 0. What do you want to choose as time equals 0? Yeah, the instant it's dropped. And what do you want to choose as time final? When it reaches the ground. So that's always based on where you have information or where you want information, or what times you have information and what times you want information. So this is the instant it reaches the ground. We don't know how long it takes. The acceleration is negative 9.81. The initial position is positive 15 meters. The final position is 0. The initial velocity is plus or minus 3 meters per second. And when it's dropped, is it going in the positive or negative direction? When it's dropped, the helicopter's on the way up, so this object is moving in the positive direction. And so we want the positive of these, and then V final is what we're looking for. So I'll use 2A times the quantity PF minus PI is equal to VF squared minus VI squared. So 2 times negative 9.81 times the quantity 0 minus 15 is equal to VF squared minus 3 squared. So that is positive 294.3 is equal to VF squared minus 9. Add 9 to both sides, and you get 303.3 is equal to VF squared. And now take the square root of both sides, but remember, whenever you take the square root of a variable, you need to consider the possibility that it's plus or minus, and you need a reason for the one you chose. So we get that VF is equal to plus or minus square root of 303.3 is 17.42. And do we want the one that's positive or negative? negative because when it reaches the ground level, it's on the way down, which is negative. Can anyone imagine what that positive 17.42 tells you pseudo-physically, you know? If this ball was launched before, like from below the ground, that's the velocity that it would be going on the way up when it passed the ground level. Okay. Anybody have any questions on that? I think that's good for today. So we'll go into new stuff on Wednesday, but I think what we're going to do for the exam a week from Wednesday is just have it on the stuff up through today. So you should have plenty of time to just refresh your memory on stuff. And remember to get ready for the quiz at the end of class on Wednesday. Okay. See half of you in lab.